Hello children, I welcome you in this video lesson of the topic torque acting on a current carrying loop placed in a uniform magnetic field. Now I have a current carrying loop. This is the current carrying loop. It is placed in the magnetic field B. Now what is our purpose? The purpose of this topic is to determine the torque on this current carrying loop. To determine the torque, we need to determine the force on the different conductors here in this loop. So we need to determine the force. So in this topic, we are going to determine the force on different conductors. Let us see that. So here is the diagram. We are at this part. In this part, we are at this part that the coil has rotated by a small angle, that is 90 minus theta, that angle, and we have to determine the force on the different conductors AD, BC, AB and CD. We have to determine the force and their direction, and we have to see that whether they result into the torque. So let us start first with AD. Now the AD part is here. The magnetic field is horizontal. It has gone a rotation of 90 minus theta. So this side, below side, that is 90 minus theta. So the remaining angle is of the magnetic field is 180 minus 90 minus theta. Hence the force on AD part is B I A sine 180 minus 90 minus theta. That is the force on AD. B I A sine 180 minus 90 minus theta. And the direction of this force is along axis. How do we give this direction? That to determine the direction, we can use our right hand, and the fingers we should curl in from the current direction to the magnetic field. So that is, we should curl our finger this way. The force is downward, and this way the force on in this part AD is downward along the axis. Now we come over to the second part, that is force on BC. Force on BC is determined as, this is the magnetic field. It has gone a rotation of 90 minus theta. So the force is B I A sine 90 minus theta. So the force on BC is B I A sine 90 minus theta along axis. Now along axis we have to see, that is the we have to curl our finger from current to the magnetic field, and that gives the force is along the axis upward. So the force is upward. Does these two forces result into a torque? No. Both the forces are along the same line of action. So therefore torque is 0. Now we come over to the conductor AB and conductor CD and determine the force on them and direction of the force on them. Now conductor AB and conductor CD. These two conductors also gone a rotation of 90 minus theta with the magnetic field, and but here what is their angle with the magnetic field? It remains 90 degree. Whatever way, whatever angle they rotate, but with the magnetic field, the two conductors always remain perpendicular to the magnetic field. Hence, what is the force on them? The force on first conductor AB, that is B I B sine 90 degree, that is sine 90 degree. BIB. That is the force on AB. So the force on AB is BIB into the paper. So how do we give this direction? So we curl our finger from current is this way, magnetic field is this way. So thumb is going this way. So the force is into the paper this way. Similarly, on this conductor CD, B, I, B. The force is B, I, B. On the CD, force is B, I, B. Out of the paper. Out of the paper, how? This way. It is out of the paper. Now there are two forces. One is out of the paper, one is into the paper. Does these two forces result into a torque? Definitely, yes, because their line of action is different. But previously, their line of action was same, so it resulted into zero torque. But this result into a torque. But the how much is the torque that we are going to see now.